Welcome back, dear students. So today we'll be starting a new chapter number 17, and very important chapter because you'll be having the continuation of the very same chapter in your class 10 also. Okay, so it's very important that you understand the concepts in class 9 itself, so that the very same concepts, whenever it comes in class 10, doesn't make any difference to you. Okay, so with that brief introduction, let's see the few topics that we need to understand here. So first and foremost, you need to understand different parts of a circle. Okay, so let's see the first part. What is radius? So radius is the distance from the center, this is called center, towards the circumference. So circumference means this boundary. Okay, so distance between the center and the boundary is known as radius. And remember, radius is always same. Okay, so if you measure this way, or whichever way you measure, that is always going to be same. Okay, right. So next is sector. Okay, so this kind of shape. Okay, so you see this black colored one, so this is called your sector. Okay, so this, see, there are, when you do this or when you draw this sector, there will be two parts being formed in the circle. Okay, so this is one part and this is another part. This is bigger part, right? So this smaller part is known as minor sector. Okay, and this bigger part is known as major sector. Okay, segment. So segment is a part of circle. Okay, so this part of circle, that is this black colored part, is known as this is known as major segment. I'm sorry, here this is called major sector and this is called minor sector. So this is also called major sector, major segment, and this is called your minor segment. Now arc, next is arc. So just a small part of the circumference or the boundary, this boundary. Okay, so this is a small part of the boundary, so this part is known as arc. Next is tangent. So any line, okay, any line which passes just or which just touches the part of the circle is known as tangent. Okay, so next is chord, very important for all of you. You need to understand this. So chord is a straight line. Chord is a straight line which passes through any point other than the center. Okay, so if it passes through center, then that will be known as a diameter. Other than this center, if there is any line like this, then this line is known as chord. Okay, circumference I have explained you. You have already learned about diameter also. So one more thing I want to say here is, remember, diameter will always be double of the radius. Okay, because radius also passes through the center and diameter also passes through the center. So that's why diameter is going to be always double of the radius. Okay, right. So let's see a few theorems that we will be making use in this particular chapter. So we have the first theorem for you. Two equal chords of a circle subtend equal angles at the center of the circle. Understand here. So there are two equal chords. So let's say equal chords are AB and PQ. So this sign means they are equal. Okay, so AB and PQ, they are equal chords. Okay, and O is the center. Now see, this AB makes an angle AOB with the center, right? So this is the angle subtended by chord AB with the center. So we are talking about the center, this angle, and the angle subtended by arc or this PQ, chord PQ, will be POQ. So we have two angles being formed here, AOB, okay, and the angle formed by other chord is POQ. So as per the theorem, these two angles will be equal. That is, angle AOB will be equals to angle POQ. Okay, now converse of theorem 1, that is, this is converse of this, just other way around. Okay, suppose if the angles subtended at the centers are equal, then the chords will be equal to each other. That's what is the meaning of this particular converse. Okay, so I expect you to pause the video and note down these theorems, because these theorems are very, very important for all of you, right? So you may pause the video and note down the theorem. We have next theorem, theorem number 2, which says the perpendicular to a chord bisects the chord if drawn from the center of the circle. So there's a chord AB, and if you draw a perpendicular to this chord from center, okay, from center, if you draw this, then this chord will get bisected. That means this AD will be equals to DB or BD. That's what is the meaning of this particular theorem. Okay, now converse is just the other way around. Okay, that is, a straight line passing through the center of a circle to bisect a chord is perpendicular to the chord, which means if you pass a straight line so that the chord gets bisected by that particular straight line, then this straight line is going to be perpendicular. That's what the converse says. Okay, so pause the video and note down the converse of the theorem. Let's have one more theorem. Okay, theorem number 3, which says equal chords of a circle are equidistant from the center of the circle. So if there are two equal chords, let's say AB and CD, then this AB and CD are going to be at an equal distance from the center. That means, see, if I draw this distance means, remember, always we measure distance in a perpendicular way. Okay, so if you drop a perpendicular, this OP gives the distance of this chord from center. Okay, and similarly, if you drop a perpendicular from O to CD, this OQ gives the distance of this chord from the center. So basically, these two distances will be same as per the theorem. So that's why we have OP equals to OQ. Okay, similarly, we have the converse of the theorem, which says chords of a circle which are at equal distances from the center are equal in length also. Okay, so this is just the other way around. So pause the video and note down the theorem number 3. Right, so having understood about the theorems, let's take few problems from your first exercise, that is exercise 17A. Question says a chord of length 6 cm is drawn in a circle of radius 5 cm. Okay, so there's a circle whose radius is 5 cm and a chord of length 6 cm is drawn. So here I see that AB is the chord, so its length is going to be how much? It's going to be 6 cm. Calculate its distance. That means you need to calculate the distance of the chord from the center. So basically you have to calculate OC. Okay, because if AB is the chord, then OC will be the distance of the chord from the center. Okay, now I told you how do you measure distance? You have to drop a perpendicular. So basically OC is perpendicular to AB, isn't it? So AB is the chord and OB the center of the circle. All of you know that. Now OC be the perpendicular drawn from O to AB, right? So OC is the perpendicular to AB, right? Now we know that if you drop a perpendicular to a chord, then the chord gets bisected, isn't it? So this is as per the theorem that we have noted down. I think this is theorem number 2. Okay, so as per the theorem number 2, we are going to have AC is equals to BC, right? So we have AC equals to BC, right? And they are going to be 3 cm each, because you know this AB is 6 cm, right? So that's why AC will be 3 cm and BC or CB will be equals to 3 cm, right? Okay, so now let's observe triangle OCA. Okay, OCA. So you know one of the angle is 90 degree, isn't it? Because this is perpendicular. So that's why, see, this is 5 cm, this is 3 cm, and if you want to find this OC, because question is asking you to find OC only, right? The distance of the chord from the center. So if you want to find OC, you have to make use of Pythagoras theorem. Okay, so by Pythagoras theorem, hypotenuse square, that is OA square, will be equals to OC square plus AC square, OC square plus AC square. So from here, bring this AC square here. Okay, so you get OC square equals to OA square. OA square means 5 square. Okay, so this comes here, becomes minus, and AC is 3 centimeter. So it becomes minus 3 square. I'm sorry, this is not cube, this is square. Okay, so see here, 5 square is 25, minus 3 square is 9. So 25 minus 9 is 16. So the value of OC square is 16. So therefore your OC, okay, that is, this turns out to be square root of 16, which is 4 centimeter. Alright, so you may pause the video and note down your solution. Let's have another question, question number 2, which says, similar kind of question is there. So first and foremost, let me draw the diagram. A chord of length 8 centimeters drawn. Okay, so a chord of length 8 centimeters drawn at a distance of 3 centimeter from the center. So this distance is given to be 3 centimeter. Okay, you need to calculate the radius. So basically OA gives me the radius, isn't it? So this is also going to be my same kind of case. So I'm not going to explain all this. Okay, so all of you know, since OC is the distance, it has to be perpendicular. So that's why AC and BC, they will be equal, or in other words, AB gets bisected. So that's why, see, you know, AB is 8 centimeter, right? So if AB is 8 centimeter, then AC and BC, okay, AC and CB, they are going to be 4 centimeter each, exactly the half of AB, right? So now again in triangle OCA, using Pythagoras theorem, we have this. So OA acts like hypotenuse because this is opposite to this 90 degree. Okay, so we have to find OA square now. So OC, how much is OC? OC is given to be 3, and we have AC, which is equals to 4. So let's put the value. So OC is 3. Okay, so this is 3 square plus this is 4, so 4 square. So 3 square plus 4 square, or 4 square plus 3 square, both means the same. 4 square is 16 plus 3 square is 9. So 16 plus 9 is 25. So from here OA will turn out to be root over 25, which is 5 centimeter. So that's why your radius of the circle is OA, right? OA is the radius, which is equals to 5 centimeter. So pause the video and note down your solution. Let's have another question. So in this question says a chord of length 24 centimeter is at a distance of 5 centimeter, like earlier one, okay, from the center of the circle. Find the length of the chord of the same circle which is at a distance of 12 centimeter from the center. Now in this particular question, you will be applying the concepts that you have learned in earlier 2 problems. Okay, so first and foremost, let me draw the diagram. Okay, so forget about this blue line. Just read the first sentence. A chord of length 24 centimeter is at a distance of 5 centimeter from the center. Okay, so this AB, okay, so this AB is of length 20 centimeter. I told you forget about this blue line. Okay, so this is your 24 centimeter, and this distance OC is given to be 5 centimeter. Okay, now will you be able to calculate the radius? Obviously, it's like earlier problem. So first find OA. So that part I am not going to show. So you will find by yourself, and it should turn to be 13 centimeter. Okay, now if OA is 13, now look at this blue color diagram. See, OA dash is also radius, isn't it? OB dash is also the radius, right? So that's why OA dash and OB dash, they will also be 13 centimeter each. Remember this, very important. Okay, right? So question says find the length of the chord of the same circle. So see, A dash B dash is also a chord of this circle, isn't it? Yes. So you need to find its length, and it is given that the distance of this chord from the center is 12 centimeter. That is OC dash is given to be 12 centimeter. Okay, so that's what I have said here. Okay, so now again using Pythagoras theorem. Okay, so if you look at this triangle, in triangle OC dash A dash, then OA dash will be your hypotenuse, right? So OA dash is square is equals to OC dash square plus A dash C dash square. Now OA dash means the radius, which is equals to 13 centimeters, isn't it? Or from here, if you bring it out here, then A dash C dash square will be OA square, which is 13 square, minus OC dash. Okay, so OC dash, this distance is given to be 12 centimeter. So that's why it turns out to be 12 square. So 13 square is 169, and we have 12 square is 144. So 69 minus 144 turns out to be 25. So from here, A dash C dash turns out to be 5 centimeter. Okay, so that means the length of the chord will be, see, A dash C dash is this much, right? So the length of the chord will be just double of this, isn't it? Because this perpendicular will bisect the chord. So that's why your length of the new chord will be double of this. Okay, that is double of 5 centimeter, which is exactly 10 centimeter, right? So you may pause the video and note down your solution. Okay, so there's one more question left. Okay, so we have done question number 4, 2 and 1, I guess. So question number 3 you will try by yourself. Okay, and with this we close for the day. Thank you very much.